When you query an AI, it instantly weaves thousands of scattered data streams together to assemble a single, highly specific answer. That speed and precision have created a persistent industry assumption that you need a completely separate set of algorithmic hacks or AI SEO gimmicks to influence the output. The reality is much simpler. Gemini is directly grounded in the live Google search index through a process known as Retrieval Augmented Generation, or RAG. Roughly half of all citations in AI mode are pulled directly from existing top 10 organic results. The engine relies on the exact same crawl data that has determined standard search rankings for years. This suggests that Gemini visibility is less of a separate tactic and more the natural result of well-structured organic search performance and technical indexation. To understand exactly how a site gets chosen, we are going to reverse engineer how Gemini pulls a citation, tracing the mechanics from the initial user prompt all the way down to the server logs. The takeaway is clear. While Gemini can reach beyond the top results, your best chance at visibility is to secure your foundation in traditional organic search first. Let's look at the very first millisecond after a user submits a prompt to Gemini. This decision tree flowchart shows how the system immediately classifies the prompt's intent. It decides whether its pre-trained model can answer the question on its own, or if it needs to trigger external data retrieval by passing through one of three specific gate checks. If a query involves recent events, highly technical schemas, or highly specific facts, the node passes through the gate and initiates a live RAG verification loop with the standard Google index. Once the search begins, the model applies an aggressive retrieval filter, the explicit rejection of generalities. Writing that exercise has many health benefits gives the AI nothing to anchor to. The system bypasses that language entirely, looking for specific data points like 150 minutes of moderate cardio per week reduces cardiovascular risk by 30 to 40%. The engine is mechanically designed to seek out concrete figures, exact terminology, and named authorities to generate reliable inline citations. Vague, generalized copywriting offers zero extractable value. To an AI citation engine seeking hard, verifiable data, those pages are functionally invisible. After Gemini decides it needs live data, the actual retrieval process begins, but it does not search the way a human user does. This diagram shows query fan-out. Gemini doesn't evaluate web pages holistically based on an overarching topic. Instead, it shatters the core prompt into several discrete sub-questions. Notice how lines extend from each sub-question to entirely different web sources. Gemini evaluates them all simultaneously. The large language model runs these individual searches concurrently to save processing time and rapidly gather highly specific context. Instead of recommending one comprehensive article, the model extracts isolated, self-contained passages from across multiple websites to assemble a single master answer. That means Gemini is citing the specific passage, not the overarching page. Rather than guessing what the model might look for, you must proactively map out these hidden sub-questions using intent research tools, targeting definitions, cost comparisons, and exact methodologies. Ranking for a broad head term guarantees nothing in passage extraction. You have to anticipate and explicitly answer the fractured subqueries the LLM is actually searching for. Surviving the fan-out process requires specific on-page architectural adjustments. We call this passage extractability, structuring your content deliberately so the LLM can lift it seamlessly without losing context. This wireframe demonstrates the core structural requirement. The surrounding narrative paragraphs fade away because every section must be entirely self-contained. It has to answer one specific question without relying on the text above or below it. If we zoom in on one block, you can see the optimal format. An H3 heading states the precise question, the paragraph immediately delivers the direct answer, and the table beneath it provides the supporting data. The LLM prefers data that is easy to parse. Procedural step-by-step lists, detailed chronological timelines, and clean markdown tables are the most reliable formats for extraction. There is a strict negative constraint here. Your key facts must reside within the text DOM. If your data is trapped in an image or a PDF, the AI cannot read it, and it will not cite it. Relying heavily on client-side rendering or complex JavaScript widgets to display your most critical data creates immediate extraction risks. If the crawler cannot parse the raw HTML, the passage is lost. Ultimately, high information density dictates which passage wins the citation. The model extracts blocks packed with specific dates, exact figures, and named entities over blocks of conversational filler. Modern web content must be modularized into high-density data blocks because the AI will strip away all the surrounding context the moment it pulls the answer. All of these passage optimizations fail completely if the crawler is blocked at the server level. Many technical SEOs make an error here by conflating Google's in-search AI overviews with the separate Gemini app. This mockup of a robots.txt file reveals the split. On the left, Google's in-search AI overviews rely entirely on standard Googlebot access. On the right, access to the Gemini app and Vertex APIs is handled by a different directive altogether. Because AI overviews use standard Googlebot access, trying to opt out of them means de-indexing your pages from Google search completely, which is a catastrophic business decision. However, you can control access to the Gemini app and Vertex API grounding using the Google Extended directive. Here is the crucial technical nuance. Google Extended is a directive, not a physical crawler. If you block it, that action will never appear in your server log files. You have to audit the live file to verify your settings. During the 2024 AI opt-out wave, many webmasters blindly deployed blocking directives, unknowingly blinding their sites to Gemini grounding without realizing the long-term impact. Failing to explicitly map and manage this bifurcated access control can silently erase a perfectly optimized, technically sound site from the entire LLM ecosystem. The final layer of optimization is removing all entity ambiguity about who you are, what you do, and what products you offer. Implementing accurate entity schema, specifically JSON LD organization data, anchors your brand's identity within the knowledge graph, making it mathematically easier for the LLM to verify your authority. Once the architecture and entity signals are in place, you have to measure the impact. But standard reporting tools have severe limitations here. Google Search Console folds AI overview performance directly into your total search performance. Cleanly isolating AI traffic in that dashboard is currently impossible. The most reliable alternative method is to segment your GA4 referral data, specifically filtering for traffic arriving from the Gemini domain. Instead of tracking traditional URL rankings, you should measure citation share, tracking how often your exact brand name is cited in the LLM's text output for your target queries. If an AI describes your brand incorrectly, it is usually a fixable entity alignment problem in your schema, not a complex algorithmic penalty. To thrive in the RAG era, ignore the AI SEO gimmicks. Fix your foundational organic indexation, clarify your entity data, and master high-density passage architecture.